Alright, today we're going to get started with operations with polynomials. And to begin, we're going to take a look at just what those are and some extra vocabulary. So a mathematical operation is a rule for putting terms together. So for example, 3x plus 5x, the operation there is plus, right? And we're going to be dealing with not just plus, but also minus, multiplication, and division at the end of the chapter. So any of these operations have their own rules for putting together terms. Another term for a single term is a monomial. And a monomial could be one of three things. It could just be a number, it could just be a variable, or it could be a combination of all of those together with as many variables as you'd like. A monomial is just one term, so there's never a plus or minus sign, it's just one thing grouped together with multiplication or division. Like terms are terms with the same variable or variables to the same powers. So the big like terms we're going to talk about would be the x squared group, which could be any number out front. They all are still like terms, so it's all about the variable part. We have our x terms, yeah, and then we also have numbers. So those three groupings are the most important, but of course there's many other types of groupings. We could look at the terms that have an x and a y in them, or terms that have a y to the fourth power, you know, and all of those group together with adding and subtracting. And we'll see that here in just a second. The word degree relates to the exponent. So the exponent or the sum of the exponents, depending on how many variables we have. So if it's just one variable raised to a power, the degree is that power. So this would be 2, this would be 1, and believe it or not, this is 0, because technically the exponent is 0. Anything to the 0 power is 1. So when you see a constant is what it's called, the degree is 0. The degree here is 8, which is super large. We probably won't be dealing with terms like that. But yes, the degree is the exponent. So how do we do this? Well, first I spot the groupings. What are my like terms? And you add them together. And when you add them together, you just add the numbers in front, because you have 2x squareds, and then you have 6x squareds. Together you should have 8x squareds. And you do the same thing with all the rest of the groupings. This is called combining like terms, right? Very doable. When you subtract like terms, or when you subtract polynomials, we want to make sure we take that negative and distribute it everywhere first. And then I want to make sure to underline or circle or whatever terms that are the same. So those are like terms. So the x cubes make negative 6x cubed. The x squareds would make minus 8. And then we have single terms that don't line up with another term in the same group, or they're different groups. One thing I want you to notice here about what I did is the exponents go high to low. The biggest degrees come first. Okay, that's called a standard form. Okay, so when you see that in directions, it's asking you to write the biggest terms first and then in descending order. Okay, so I've said it a little bit already. A polynomial is either just a single monomial, or it is the sum of a few different monomials. So one example of a polynomial is this: 3 monomials together. But this right here is also a polynomial. It just happens to be a monomial. There's just one term. Okay, and when we talk about degree, we're talking about the degree, the highest or largest exponent, which in this case would be 4. So this is a 4th degree polynomial. So it all depends on ordering these and putting the biggest one first, and that is your degree, the exponent on the biggest term. So this table is real nice. I'll be using this probably on a test with different polynomials and different things filled in. But so I already said this before, a number alone is called a constant, and the degree is 0. A polynomial is called linear if the degree is 1. So this degree, or the power right here, is a 1. The next one has a degree of 2 because it's the biggest exponent, and that's called a quadratic. And finally, we have a degree 3, which is called cubic. All the words that you maybe have heard before. And if you have 4th and 5th degree, they also have names, quartic and quintic. Probably won't be touching those at all, but if you do see those words, that's what they align with, the biggest exponent. So we can name them by the exponent, by the degree, or we can name them based on how many terms there are. So the first one has 1 term, 2, 3, 1. Just counting the number of items separated by addition or subtraction. So the name for 1 term is monomial. I've already done that. So that's true here and here. 2 terms is called binomial, like a bicycle, right? 2 wheels. And like a tricycle, you have trinomial. All right. So all of that vocab, there's 8 different, or I guess 7 different words for us to know and learn. So every polynomial kind of has 2 names. So let's practice that here. So first it says standard form, and then classify based on degree and on number of terms. So it's 2 different names. First things first here, I do have 2 constants, and they actually cancel each other because 15 minus 15 is 0. So I'm going to reorder this in standard form. And so degree. I have, it's 2nd degree, so that would be quadratic. And for the terms, there's 2, so this would be a binomial. Okay. Here I immediately see that these are like terms, so I'll combine those. And I have no other sort of grouping. So I'm just going to reorder them, biggest exponent to smallest exponent, and then I'm ready to name this. So by terms, there's 3 of them, trinomial. For me, I always think nomial is kind of like name, right? Name and also number. So I see like 3 number, so 3 terms. That's how I get those straight. And with degree, I know it's either linear, quadratic, or cubic. This one's cubic because that is the highest degree. Okay, so go ahead and practice these. Pause the video, try these out, and check with the key. I think number 4, I made a small mistake, so watch out for that. But let's now take a look at multiplying these together. So we need to remember some exponent rules. If you multiply monomials together, or variables together, we have to add the exponents. So this will be x to the 6th, and this would be y to the 8th, since 7 plus 1, right? The way that we break this down, and this is how I kind of remember it, is x to the 4th is x squared is x, and together that's 6 x's multiplied, so it'd be x to the 6th. So that's kind of why that rule works. So let's distribute and practice with these examples here, and then that'll be it. So distribute here. So I multiply the numbers separately, and then I multiply the x's together. Okay? And then I multiply the second arrow, and the double negative makes a plus. Okay? And it says classify the resulting polynomials as well. So this would be a trinomial, or I'm sorry, not a trinomial. There's only two terms, binomial and cubic. Okay. You can actually also distribute from the right side like this, also legal. So 2x, so this one's a little, maybe we should write this down. So 2x times 9x to the 4th is the same as 18 times x to the 4th, right? Because these are 4 things multiplied together, and you can order them however you want, and it ends up being 18x to the 5th. The next one would be minus 4x to the 4th, and this last one would be 14x. Okay, this would be a trinomial. The number is 3 terms, and we have actually a quintic here. Okay, or you could also say 5th degree. Okay, and we've done these before when you have two things, the binomial times binomial. The acronym is FOIL, first, outer, inner, last. So I'd multiply those together and then do the minus 5x minus 12x plus 15. Okay, it's important to combine like terms after this so that we know that this is in fact a trinomial and it's quadratic. Probably our most common polynomial for this section in this chapter. So make sure you're good on FOIL. Let's see that again. So now we actually have 3 and 3 to go to, because everyone has to be distributed to. Okay. Each term, there's 5 of them really, and they all must touch each other. So the first one is 6x cubed plus 2x squared minus 10x. That was the upper. And then the next one right here would be minus 21x squared minus 7x plus 35. And if I go down the line here, I've had a lot of practice with this, so I do it a little faster. But make sure if the underline helps you, I say go for it. I saw that the x squareds combined, and so did the linear terms. So honestly, no need to really underline that at all because it's by itself. But yeah, so this looks like it has 4 terms, which is not a special name. It stops at trinomial. And this looks to be a cubic. Okay. And finally, when we have that squared, that means that it's 2 copies multiplied. So I'm going to rewrite it like this. And then my job is to distribute. So So those are my first two distributes that I did. And then I have plus 7x plus 49. And altogether, we get this, which is a quadratic. Got that squared, and it's a trinomial. Okay? Alrighty, so those are plenty of examples. Hopefully you got those down in your notes. And go ahead and try these problems down here. They're almost exact replicas, just with different numbers. And check with my key and see what you get. Okay. Thanks.